Hello, um, how are you doing today? Welcome to my YouTube channel. My name is Isioma Owanyo, and I am a graduate student of the Department of Geography at Indiana University, Bloomington. And today I would be talking about drought generally in West Africa. Okay, so the objectives of this presentation are to compare the SPI and the SPE to see how these different drought indices um, give different results of dryness in West Africa. So the SPI is the standardized precipitation index, and the SPI is the standardized precipitation evapotranspiration index. They are both drought indices that give different values based on the wetness or dryness of a particular region. So they are used for drought evaluation. I'm talking about that as we go on in the presentation. I'll also be looking at climate change trend in the region. I'll be investigating the impacts of these droughts. And also I'll be giving suggested solutions based on other research that's been done earlier. So keep your seat belts on and let's do this. So what is drought? Drought basically is precipitation deficits in some cases, while in some other cases, the combination of both precipitation scarcity and high temperature that leads to an high evapotranspiration rate. So when we have precipitation deficits and we have an high evapotranspiration rate, it causes dryness. So there are four major types of drought. The meteorological drought is highly dependent on precipitation over a shorter period of time compared to the other type of drought. While the agricultural drought is both influenced by precipitation and high temperature, and high temperature that causes decline in soil moisture. And for the hydrological drought, it occurs when we have a very long agricultural drought that causes a decline in runoff, discharge, groundwater, and reservoirs. And for the socioeconomic impact, these are the impacts of these three other droughts on a particular location. So I hope we got that. So this is a map of West Africa showing the different climatic zones. And the West African climate is highly influenced by the intertropical convergence zone, which is created by two air masses, the southwesterly air mass and the northeasterly air mass. The southwesterly air mass originates from the Gulf of Guinea and is usually moist, wet, while the northeasterly air mass originates from the Sahara Desert and is usually dry. So this means that most regions in the northern part of West Africa are usually dry compared to most regions in the southern part of West Africa because of the differences in these two air masses. And the different climate zones we have are the Guinea, Sudan, and Sahel. Sometimes this is classified as the savanna or is splitted into two to have the Sudan and the savanna climatic zone. Yeah, so it's a fact that West Africa is one of the most vulnerable regions to climate change. And since the 1970s, there have been recurrent cases of agricultural losses, environmental degradation, food scarcity, droughts, and extreme flooding. And from my research, I got to discover that West Africa is one of the most vulnerable regions to droughts because there is an high dependence on rain-fed agriculture, dust feedback from the Sahara Desert that's just above the West African region. There's intense farming that results in soil crusting and desertification. And then we have climate change. So let's take a look at climate change. So to understand droughts in West Africa, we actually need to understand the historical pattern of climate change in the region. And from here, I adopted the linear trend of temperature and precipitation from 1983 to 2010 from Sahel to 2016. And the map was gotten from, or the data for the map was gotten from the Climate Research Unit. And from here on the left-hand side, we can see precipitation trend. And we can see that although precipitation has been increasing from about 0.2 millimeters to 1 millimeters per day, research has shown that the seasonal precipitation recovery in the Sahel region has not been sufficient for the drought of the 1970s and the 1980s. Now, before I continue, I would like to say that the Sahel region is one of the most vulnerable regions in West Africa to drought. And this actually shows us that the period before the early 1980s must have been a very dry period, and it is most likely to occur in the future. And so we are more likely to get more drought in the future. While on the right-hand side, we can see temperature trend from the same data source. And we can see that a larger percentage of the West African region is experiencing significant warming, ranging from about 0.2 degrees Celsius to more than 0.5 degrees Celsius per decade, which is a high rate of increase when compared to the global rates of warming. So I also looked at projections of climate change in West Africa. And from the left-hand side, we can see that temperature is projected to increase drastically in West Africa by the end of the 21st century, while on the right-hand side, projected precipitation shows a less evident trend, but then we have more visible annual variabilities. So these projections were made based on the RCP 8.5 and 4.5. The RCP is the representative concentration pathway, which is a greenhouse gas concentration trajectory adopted by the IPCC, the Intergovernmental Panel on Climate Change. So what it basically does is to show the amount of climate change we're estimated to have, or the amount of increase in certain climate elements that we're supposed to have based on a particular amount of greenhouse emission. So the RCP 8.5 gives the highest amount of emission possible, while the RCP 4.5 is just in between, because we have the RCP 2.0 and 2.6 and 6.0. So this suggests that there would most likely be more drought events, since we have a very evident increase in temperature to about 6.0 degrees Celsius by the end of the 21st century, and more interannual variabilities of precipitation. Now to drought indices. Drought indices are useful for comparing the influence of different climate elements on drought. And for this presentation, I'll be comparing the SPI, Standardized Precipitation Index, that uses solely precipitation for drought evaluation, and the SPEI, the Standardized Precipitation Evaporative Transpiration Index. So from the table, we can see the different classification of dryness based on the different values that are derived from SPI and the SPI analysis. So more than 2.0 shows that a region is extremely wet. And when we have less than minus 2.0, it shows that a region is extremely dry. So we start having some amount of dryness when we have a value of minus 0.992 to minus 0.5. So what are the drought indices projections under different representative concentration pathways in West Africa? So this is a drought indices time series in the Guinea coast. The Guinea coast is the wettest region in West Africa because it's close to the Guinea Gulf, just like the Guinea Gulf. Just like I explained earlier, it is mostly affected by southwesterly winds, compared to the northern parts where we have the Sahel region that is mostly affected by the northeasterly winds that originate from the Sahara Desert. So from here, we can see the different groups. For A, this is the SPI time series for 3 months, 6 months, 12 months under the RCP 4.5. And for B, it is the SPI values for 3, 6, 12 months under the RCP 4.5. So the same applies for C and D. The only difference is that this is for the RCP 8.5 and this is for the RCP, this is the SPI for the RCP 8.5 also. So we can see that we can say 3 months can be likened to the agricultural drought. 6 months can be, 3 months can be likened to the meteorological drought. 6 months can be likened to the agricultural drought, and the 12 months can be likened to the hydrological drought. Since these different categorization of droughts are based on time scales, the meteorological drought takes a relatively shorter period of time compared to the agricultural and the hydrological drought. So from here, we can see that although there have been projected amounts of wetness in this region based on the SPI, there is still some projected amount of dryness also. And I should also note that the SPI is more sensitive to drought since it combines two climate elements, the evapotranspiration and the precipitation. So many studies have shown that the SPEI is more likely to give an accurate evaluation of drought compared to the SPI because it uses two climate indices or two climate elements. So we can see that for the RCP 4.0, we are still likely to get some high amounts of precipitation drought, agricultural drought, and meteorological drought, agricultural drought, and hydrological drought. And under the highest scenario of greenhouse emission, we are projected to have more dryness in West Africa. So this shows that even in one of the wettest regions of West Africa, there's still a high projection of dryness in the region. And when we compare it to the Savannah region, which is just in between the Sahel and the Guinea region, we can see that we have more red values, so more dryness. And lastly, the Sahel region, which is like one of the most vulnerable regions to climate change or drought, we can see that we have an increased amount of dryness. And in some cases, under the RCP 4.5, we can see the value going below -2, which is an extremely dry situation that could lead to an increase in droughts, a high amount of droughts that could actually eventually lead to desertification. So what are the impacts of droughts in the Sahel region? So a study by Ilsen 2012 shows that drought has caused scarcity of clean water, reduced food yields, famine, hunger, forest decline, and it's most likely to cause desertification. And from this image, you can see that about 15.6 million people are affected by drought in the region. It has caused 20 to 60% increase in the prices of food, increase in the amount of locusts that affect plants, 25% decrease in food production, and the list is endless. So drought is a very, very important issue in West Africa that has to be dealt with before it causes desertification and leads to more harm in the region. So some of the suggested solutions I have to drought are based on two categories. The first is the immediate measures to actually drill boreholes for people who do not have access to clean water so they could get water. Although that will be very difficult because most regions are very dry, but if it's possible to get boreholes for them to have at least water for their daily use. And also for rainwater harvesting, effluent treatment and reuse, which is the treatment of waste water, which I feel like the IPCC and the United Nations could actually do, adopt technologies that could help them change their wastewater into clean water that they could use. And then for the long-term measures, wastewater storage and transfer development could be used, desalination, which is the removal of salts from water to have fresh water, and the management of deforestation and agriculture. So like I said earlier at the beginning of the presentation, one of the major reasons for droughts is the increasing rates of farming and deforestation. So maybe if there's a reduced amount of deforestation, would have less droughts in the region, especially in the Sahel region. So in conclusion, droughts has been one of the most devastating and expensive natural disaster because it causes other events. Apart from just drought, it causes other events. It leads to food reduction, it leads to hunger and famine, increase in food crops, it leads to diseases and sickness, and increase in pests and parasites. So we can adopt adaptive strategies to lessen the impact of this disaster and prevent them from occurring entirely by bringing in new ideas and actually working towards caring for our environment. So we can see from the RCP different representative concentration pathway that temperature is projected to increase in this region and precipitation is showing a less evident trend. So maybe if we generally treat our environment better all over the world by taking little steps as little as choosing to use less fossil fuels, adopting better strategies, we could actually reduce the likelihood of having droughts in West Africa and some other extreme climate change events in other parts of the world. So that will be all for me today. I am looking forward to uploading more presentations, more projects, and more interesting topics on climate change. So thank you very much. And this last slide is my reference, shows my references where I got all my materials from. So thank you. Have a great day and see you later.